Hello, this video is an introduction to organic chemistry. We all know there are 118 elements in the periodic table. The most amazing one is the carbon atom. Why? Because carbon atom contains more than 10 million compounds. Other 117 elements form compounds altogether less than that of carbon. Main sources of the carbon are organic living or once living materials in animals and plants. Carbon compounds with hydrogen-carbon bonds is the branch of chemistry known as organic chemistry. Some of the carbon compounds do not have hydrogen-carbon bond. They are included in inorganic chemistry, such as carbon dioxide, carbonates. The cells in our bodies, the clothes, fibers, plastic plates, food on the plastic plates, almost everything in this bottle consists of organic compounds. There are two main reasons why carbon forms so many compounds. The first reason is that carbon atoms form branch chain, rings of varying sizes. And second reason is that the relative inertness of carbon-carbon bond and carbon-hydrogen bonds because of their relative high bond enthalpies. The following terms are explaining. A functional group is the group of atoms which gives an organic compound its characteristic properties and reactions. Hydrocarbon compounds consisting of only hydrogen and carbon. And homologous series, a family of compounds, contains almost the same functional group. A general formula represents a homologous series. Carbon often form also bonds with nitrogen, oxygen, sulfur, halogen. A knowledge of organic chemistry enables chemists to synthesize and manufacture a wide range of important products, including fuels, plastics, medicines, and antibodies. Ethane and ethanol look very like in their structures, but they do have different properties. As I said, ethane and ethanol look very similar structure. This is what is ethane and that is what is ethanol. Here is the structure of ethane. Ethanol structure, is it not? They look very similar in structure. Structure of ethane and ethanol. Do they look like same? Almost same, is it not? But they do have very different properties. Ethane, gas, ethanol, liquid at room temperature. Ethane doesn't react with the phosphorus pentachloride. Ethanol does react with phosphorus pentachloride, giving hydrogen chloride gas. The functional group in ethanol is OH group, which we call hydroxyl group. Functional group of a molecule responsible for the most reactions of the compound. However, the carbon-carbon bond and in the compound is rather unreactive. Now you see this, what I have already talked a little bit of structure of ethane and ethanol. However, if we take ball and stick model of ethanol, you can see this is the reactive group and only one functional group in this compound, the structure of ethanol. And then next one is having two functional groups, the structure of lactic acid, whereas one hydroxyl group is one functional group and a carboxylic group is another functional group. So we can have very many functional groups in compounds, one functional group or more than one functional groups in organic compounds. Now I talk a little bit about some very common functional groups. As I say, alcoholic functional group, and then another ethene group, functional group, alkynes group, functional group, halo group, and then ether groups, and then aldehyde groups, functional groups, and then ketone groups, and then carboxylic groups, and primary amine functional groups. And we have the examples of these functional groups in the slide. For example, ethanol, and then ethane, and then ethene, and then chloroethene, and then methoxyethane, ethanol, propane, and then ethanoic acid, and ethylamine. Here we can see the structural formula, displayed formula, and skeletal formula. This slide shows molecular formula, structural formula, displayed formula, skeletal formula. And what is molecular formula? Just composition of elements. And structure formula shows minimal details which atom or group of atoms are attached with each other. But displayed formula shows atoms and all the bonds between the molecules. And skeletal formulas simply the functional group. Rest are all in with a skeleton. If I explain this, we can see here is the skeletal formula of structural. There is the structural formula, displayed formula, here is the skeletal formula. Similarly, this is the structural formula, this is displayed formula, this is skeletal formula. I say in skeletal formula we only show the functional group. We were talking about homologous series. We can have general formula for the homologous series. A alkane, general formula is CnH2n plus 2. Alkenes, general formula CnH2n. And a haloalkenes is CnH2n plus 1x. In this slide, I'll show you a number of alkane family, such as methane, ethane, propane, butane, pentane, hexane, heptane, octane, nanone, decane. This is a very important and interesting thing that we talked about millions of organic compounds. If we do not have rules and regulations how to name them or how to draw their structure, we will have problems. And you know, IUPAC, which means the International Union of Pure and Applied Chemistry, is the recognized authority of naming chemical compounds. IUPAC has rules which make it possible to work out the structure of the compounds and its name, or vice versa. I showed in this slide naming as per IUPAC system of some organic compounds, not all, of course. For example, we are naming pentane and branch pentane. When you name, we have to see about the long chain of carbon, and we have to identify the long chain of carbon first, and then look about the branched chain. In the first example, you see that we have pentane. That means we have 5 carbon atoms. And then we have a chain group of atoms. Then we have to count the long chain first, and as per IUPAC, we have to number them from the right to left, the carbon chain. Here you see the 1, 2, 3, 4, 5. And then in 2 position, we have a methyl group. So we call it 2-methyl pentane. Do remember, if we start counting from here, it becomes 4-methyl pentane, is it not? 1, 2, 3, 4, 4-methyl pentane. But IUPAC, rules of IUPAC, call it 2-methyl pentane because you are counting the number of carbon atoms from right to left. Similarly, we go for the next one. We look for the long chain carbon, and here you see that if we count the number of carbon, 1, 2, 3, 4, 5, 6, and 7. In any way, if you count from here, go there, you don't get 7. If you count from here, go there, you don't get 7. So this is your long chain carbon. And next, then we have to see what are the branch chains. Here we have 2 branch chains. One is at 3 position, another is at 4 position. So what you call 4-ethyl 3-methyl pentane. Do remember also the branch chain to be named according to alphabet. So please note that I have made a mistake naming this second one. I just said pentane. It is not pentane. You do see that this 7 carbon atom. So it is heptane. So we call it 4-ethyl 3-methyl heptane. So 4-ethyl, here is the branch 4-ethyl group, and here is 3-methyl group. So you might say, why do I say first ethyl and then methyl? It is, we have to name it as per alphabetic order. Therefore, 4-ethyl and 3-methyl heptane. Similarly, we go for here. Now we see that you have another example of naming of hydrocarbons. So here we again count the number, and it is 7 in number, is it not? And therefore we call it 4-ethyl 3-methyl heptane, not 3-methyl 4-ethyl heptane. So this is how we name it, but I have simply showed you how IUPAC named all the organic compounds. Not only organic compounds, IUPAC is responsible to name all chemical compounds, and we have to follow the rules of IUPAC to name them. I hope this lecture ends here, and we will be having more live interactive sessions later. Please do register in the following link.